Everyone, Mrs. Jones here. In this video, we are going to start equation solving part 2. And so the first piece of equation solving part 2 is going to be something called fractional equations. In other words, we are going to have equations with lots of fractions in them. And instead of trying to figure out how to add fractions and divide fractions and multiply fractions, etc., there's actually a way to be able to clear the fractions out of the entire equation. And so that's what this video is going to focus on. But before we dive into that, I want you to just do a quick little recap, quick little riding a bike back to the basics of how to solve an equation. You've spent a lot of time doing this so far this year, so I want you to pause the video here and try this first equation. All right, you're back. Hopefully this went well. You're going to remember to always use the distributive property and hopefully combine your like terms, isolate the variable by using inverse operations, and your final answer here should be negative 13 over 5, or negative 13 fifths. Okay, so what happens then if we have something like this? Well, what gets tricky is that this is an expression, not an equation. So with an expression, we need to think about how can I combine these like terms? Well, they're fractions. With fractions, if I'm combining like terms, I'm thinking about adding and subtracting, I want to think about a common denominator. So if I look at my 2, my 3, my 4, and my 2, I want to think about what is a number, or in other words, the LCM, the lowest common multiple of those three numbers. So the smallest number that 2, 3, and 4 go into. Well, hopefully you know that 12 is going to be our magic number here. So I'm going to rewrite each of these fractions with a 12 in the denominator. Okay, so if I'm going to change my x over 2, I could put an invisible 1 right here. I basically have 1/2 x. I know I can change that to be 6x over 12. For me to go from thirds to twelfths, I multiplied by 4, so I know the equivalent fraction is going to be 8/12. For me to go from fourths to twelfths, I multiplied by 3, so the equivalent will be 9/12. And then we know 1/2 is the same as 6/12. So now that I'm in twelfths, I can now combine my like term. So let's see. I could rewrite this right here as 6/12 x, right? It's the same idea as me saying 9/12 x. So I'm going to rewrite these two and put them next to each other, these two right here. Then I also have negative 8/12, negative 8/12 minus 6/12. So now when I combine my like terms, if I have 6/12 plus 9/12, I know that's going to give me 15/12 x, because remember when we add fractions, we just add the numerator. And then that's going to get me negative 8 minus 6 is going to be negative 14/12, or minus 14/12. So then I can simplify these. 15 over and 12 are both divisible by 3. So I'm going to end up with 5/4 x minus 14 and 12 are both divisible by 2, so it's going to be minus 7/6. And it's okay here to leave your fractions as top-heavy fractions, just as long as you remember to simplify them as much as we've done, which is what we did to get to the red. So now what happens, though, when we have an equation? When we have an equation, there's actually something else we can do. So instead of thinking about a common denominator and changing all of my fractions to be, again, here in terms of twelfths, I actually want to think about what number could I multiply that can clear the fractions. And it's the same number that we would use if we were going to put them into a common denominator. So again, I'm thinking about that idea of the LCM. So the LCM of 3, 2, and 4 is 12, meaning what is the lowest common number, lowest common multiple that they all go into. So what I can do is I can actually multiply this entire equation by the number 12. And when I say entire equation, I mean everything on the left side and everything on the right side. And so what happens is I end up with an equation without fractions. Amazing. Well, let's double check this here. If I distribute my 12 into the 2/3 x, let's think about that. What is 2/3 of 12? 8. So I end up with 8x. Okay, we should feel really good about half of 12 being 6. Remember, we're doing it all the way through. So I'm also going to do 12 times 2, which is 24. And then I'm going to do what's 3/4 of 12, and that's 9x. And again, because we've done the same thing, what I did to one side, I did the same thing to the other side, my equation is still balanced, And now I can move forward without the fractions. So hopefully now that you see this purple equation, again, we're back to riding a bike, the beginning of 7th grade. This should feel really good. We're going to move things to each side. So I'm going to take, see, the 9x away from here and the 6 away from here. So I'm combining my like terms on each side of the equation. And I'm going to end up with negative x equals 18. Remember, we don't want negative x, we want positive x. And there's an invisible 1 right here. So I'm going to divide by negative 1 on both sides. And my answer will be x equals negative 18. All right, I would like you to try this next one on your own. First, think about, what do I need to multiply? What is the LCM of my denominators? What's the LCM of 5 and 2? All right, you're back. Hopefully, you saw the LCM of 5 and 2 is going to be 10. So I'm going to multiply both sides of my equation here by 10. Then I will get a magical equation that has no fractions. So when I distribute, what is 1/5 of 10? That's going to get me to 2x. I'm going to distribute the 10 even to those integer whole numbers. I'm going to get negative 10. When I distribute here, 3/2 of, so what's 1/2 of 10 is going to get me to that 15x. And when I distribute the 10 to the x, it gets me to 10x. I will tell you the number one mistake that kids make in this unit is that they don't distribute all the way. They forget about those whole numbers. They forget about the fractions. Remember that, share the love, give that 10 to everything. So now we combine our like terms, right? 15x and 10x is going to get me to 25x. I'll move my 2x to the other side. So I end up with negative 10 equals 3x, excuse me. And so that tells me that x equals negative 10 over 23. All right, let's try another one. Think about, what is my LCM going to be of 2 and 3? Pause your video here and try it. All right, you're back. Hopefully you multiplied everything by 6. When you did that, your resulting equation should have been 3x plus 2 minus 6x equals 4x plus 6. When you combine your like terms and do all of your work, you should end up with x equals negative 4/7. Feel free to pause the video here if you want to look through my work in a little bit more detail. All right, hopefully this is feeling good. We're going to do one last type of question together, which is a little bit harder. Notice here that my numerators, right? Remember, your numerator is what's on top. They're a little trickier. They're a little more complicated. And so what I want us to do is think about strategies to make this easier for us. Well, my first tip is that when you have parentheses within your numerator, I would automatically just go do that distribution. So this is going to become 2x plus 2. So that's going to be a lot easier for me to work with than these parentheses. So now I want to think about, what is my LCM? I have denominators of 3 and 5. So my LCM here is going to be 15. So I'm going to multiply this entire thing by 15. So now let's distribute. Well, this is the same thing as saying 1/5 x. So I know 1/5 of 15 is 3. So that feels good. That's going to be 3x. Well, now let's think about this tricky fraction with a lot going on. This is saying I want 2x plus 2 divided by 3. So here's my tip. First, we're going to find what's 1/3 of 15. That 1/3 is coming from the fact that I could really think about this as being 1 over 3, right? This 3 here. So 1/3 of 15 is 5. And so I can think about this as being 5 times that 2x plus 2 in the numerator. You almost separate out the numerator from the rest of the fraction, if that makes sense. We're going to do it again in a second. You'll see what I mean. So we've done this here. Now I need to give the 15 to the 1. Hopefully that feels good, of just being plus 15 equals, this is going to get me to 15x. And here, now I have another tricky situation. We are going to think about this as just being 1/5 of 3x plus 4. So 1/5 of 15 is 3. So I'm going to think about this as being 3 times that numerator of 3x plus 4. All right. Now, the purple should hopefully feel really good. That's just like a regular equation you've been solving. It's tricky, but you can do it. So I'm going to end up with 3x minus 10x minus 10 plus 15 equals 15x minus 9x minus 12. When I go and combine my like terms on each side, I'm going to end up with negative 7x plus 5 equals 6x minus 12. I'm going to combine things on each side of the equation. So I should end up here with negative 13x equals negative 17. And you're going to divide by 13. Oops, boy. Divide by negative 13 on both sides. And we should get, let's see, 17 thirds. There we go. All right, so I know that first part was tricky, but I would encourage you to think about your denominator and taking that fraction of 15 and then distributing it. So again, I'll just show you one more time what I mean by that. I'm thinking about this as being 1/3 of 15, which gets me to that 5. And then my numerator comes down. Okay, here I'm thinking about this being 1/5 of 15, which is 3. And then my numerator came down here. Okay, so hopefully that helps. I promise we're going to do a bunch more practice in the next couple of days in class. If you have any questions, please just ask, and good luck on your homework.